In July 2008, the Electrical Engineers Association produced a revised guide, Work on De-Energized Distribution Overhead Lines. The guide includes good information on creating an equipotential zone on wooden poles and concrete poles with an integral earth. However, there is some concern within the industry about aspects such as ground control issues, the possible introduction of multiple trip hazards aloft, and concrete poles without integral earths. The latter is especially important, as most of the concrete power poles in New Zealand do not have integral earths. However, the good news is that there is now a way for you to actively and safely manage all three of these issues. Dialectric has developed a methodology that meets the requirement of the guide, as well as those in the SMEI handbooks. This video shows you the equipment we have developed and how to use it. As with any work, employees must undertake a tailgate process to determine the possible hazards on the job and to also discuss the methodology that will be used to complete the job.
We've heard from the control room we have a clearance to open ABS 559.
Understand, we've got a clearance to open ABS 559.
Once the tailgate has been completed, isolation of the network can commence.
Okay, hold it there, I'll check the switch. I've checked the switch, it is completely open, all blades have completely disconnected. You may fit a private lock and multi-lock.
Those employees involved in the switching should be wearing the appropriate personal protective equipment, including Dialectric footwear.
Okay, Will, so we're having an HV shutdown. So
when the area has been isolated, workers must decide on what methodology they will employ to reduce the risk of inadvertent single-phase livening.
The first question is inadvertent livening possible? And the answer is yes. Now, what can we do to prevent that? Can we remove jumpers? In this instance, I think for the job that we're doing, it's going to be a little bit too hard and involved to do that.
Creating a barrier around the work area prevents those without dielectric footwear from entering an area where there may be a risk of step potential. The dielectric boots are manufactured locally and sold through SafeWorks. They have steel reinforced toe caps as well as sole inserts for comfort. Before they were accepted as suitable to this purpose, techs on-site conducted stringent tests on the boots, subjecting each one to 10 kV for 1 minute. Once tested, the boots were stamped with the voltage level used and the next test date. Dielectric boots are like rubber gloves and should be treated in the same manner. They must be electrically tested every 6 months, stored in their own bag, and field tested before every use.
We'll test our dielectric footwear. So we'll do a visual inspection first, make sure there's no cuts or splits, exactly as you do to a glove. And then the beauty of these particular boots is you can do a field test as well. So they've actually got a test date on them and the standard that they've been tested to, their voltage rating. So we can do a field roll test to test the integrity. So exactly like a glove, do it to both boots.
After the field test, the boots must be worn for the total duration of the outage. Dielectric boots give the worker complete freedom of movement around the site, as they provide isolation from any step potential that may exist. The added benefit aloft is that the boots help prevent contact between the worker and the pole. This protects the worker from a potential voltage difference. All Equipotential bonding equipment is checked in and out of the worksite. This ensures that no equipment is left on site or, more importantly, left aloft.
The shroud and the jumper lead are all good.
Immediately before use, the workers must examine all equipment to ensure that it is in test, free of defects, and in good condition. It is best practice to fit LV guards between the two central wires that the worker will climb through. They now no longer need to shroud the remaining LV conductors, as the dielectric footwear provides the isolation they need.
Okay. We've put our earth pin in the required depth. Now we're fitting our single lead earth clamp to that. Got it nice and tight. And now we'll attach our earth stick attachment to the fuse stick, making sure it's nice and tight, not going to come undone. Load our cat of earth. That's all loaded, ready to go. All yours?
Earth should be fitted to either side of their work position as per the SMEI handbooks. Where there's a multi-pole shutdown, there must be earths within 5 metres of the work position. Electrics is moving to the K2 range of earths, as these are easy to apply and store. They also create less of a hazard aloft by using the conductor as a common point, instead of the usual star configuration of traditional earthing sets. Another added advantage is that they don't have long handles that are prone to damage. The primary role of the pole shroud is to protect the worker from the potentially conductive pole. When used in conjunction with the dielectric boots and gloves, this meets the requirements of the SMEI handbooks. We developed the pole shroud in conjunction with the energy network. It's been tested by text on site at 10 kV for 1 minute, giving it a Class 1 working voltage of 7.5 kV. Before the application of the shroud to the pole, it should be visually inspected to ensure that it's free from damage, splits or holes. The shroud has been cut to fit neatly around the pole and arm braces. If any other equipment such as streetlights or stay wires protrude from the pole, the shroud will accommodate these through a Velcro split. The shroud is large enough to fit a double pole if needed. Importantly, the shroud design allows the worker to place standing bolts in the pole. All exposed metalwork should be bonded to a common point. The EEA guide recommends a copper lead of at least 25 mm square. Electrics has developed a practical lead consisting of 3 battery jumper clamps and a copper braided cable of the required size. Due to its unique design, one lead can bond several items.
So we're actually now ready to do our work. We've got our earth leads line earthed, we've got our pole bonded. We are protected from touching the pole through our pole shroud, our gloves and our Equipotential Bonding boots, so we can freely move along throughout the site. We've introduced no other trip hazards. There's no other hazards that we've introduced, so we can commence our work.
The Dialectric's Equipotential Bonding solution is a quick and effective way of mitigating the risks should a single-phase livening occur.
Hey Graham, so we've finished our work, so what we've got to do is check in all our gear that we've been using for the earthing.
When all the work has been completed, the setup can be dismantled in the reverse order of application. First bonding leads, then shrouds, then earths. Once all equipment has been returned to ground level, and before the access permit is cancelled or returned, all equipment must be checked in to ensure that nothing has been left aloft. With help from the energy network, Electrics has designed a bag that holds the shroud, bonding lead and barrier.
Okay, understand Graham, I've got permission to close ABS 559.
Yep, got permission to close ABS 559.
Roger that.
The Dialectric Equipotential Bonding solution offers a number of benefits. The process lets the worker determine what options they have to either mitigate the risk by removing the chance of a single-phase livening, or to follow the process outlined in this video. Dielectric boots give complete freedom of movement around the site by isolating the worker from any step potential voltages. The barrier provides a simple, effective way to demarcate the potentially hazardous zone and prevent those without appropriate dielectric footwear from entering. A thorough checking in, checking out process ensures that no equipment is left aloft at the conclusion of an outage. The latest design in overhead earthing protection creates a less hazardous environment aloft. Using the conductors as the common bonding point, it is also easier to apply. Workers are protected by shrouding conductive parts of a pole and by wearing dielectric gumboots and rubber gloves. Rather than introduce additional trip hazards aloft by having the common bonding point below the LV, we apply the main earth and bonding lead to one of the overhead conductors. This has the added benefit that there is no chance of an earthed bonding lead to fall across any live LV lower down. It also reduces a significant trip hazard by having the bonding lead coming down rather than up. The bonding lead can also be used on concrete poles with an integral earth and on wooden poles. From all of this, it should be clear that the Dialectric's methodology has significantly reduced risk. The equipment is easily installed. It effectively isolates the worker from contact with any potential voltage differences if a single-phase livening should occur. All equipotential bonding equipment has been color-coded yellow. This makes it highly visible so that you can easily identify all associated equipment and you can quickly check that all equipment is in place. In developing the solution, Dialectric has enjoyed significant support from some of the top companies in the electricity industry. The Energy Network offers a large range of quality tools and equipment for the construction and maintenance of electricity networks. They have worked closely with Dialectric to design a working EQB pole shroud to meet the requirements of the guide. The EQB pole shroud is high strength, fabric reinforced, puncture resistance and 2-color for added safety and easier visual inspection. The Energy Network is also the exclusive distributor for lightweight aluminium Katu earths in New Zealand. Utilitech is an NZQA and EWRB accredited training provider to the electricity and gas distribution sectors. They have been a part of Dialectric's initiative to develop a viable solution to protect those working on concrete poles that do not have an integral earth.
Good morning, SafeWorks. How can I help you?
SafeWorks is a complete safety supplier. This New Zealand-owned and operated company takes pride in providing practical and cost-effective solutions that are innovative and suitable in real work situations. They developed the Dialectric boot in conjunction with Dialectric. Tex On-Site Limited provides the only truly mobile testing and calibration service in New Zealand. They supply a true one-stop compliance management system for businesses in the electricity industry. Their services even extend to the repair of equipment and replacement on-site. Tex On-Site did extensive testing of the Dialectric boot developed for the Dialectric's EQB method.